Good afternoon, guys. I'm back to help you with quadratic transformations. It's basically how the parent function of a quadratic graph compares to a one that's been shifted or widened or stretched or anything like that. Please follow along with me. I'm doing some examples from your lessons for the week. So if you watch this video and the video from last week, you should have at least 4 to 5 examples on each activity. This slide would be very helpful in understanding the transformations. This is from vertex form. So you have A, which is the value that tells you if it reflects or if it stretches or compresses. If A is a number that is greater than 1, meaning it is any number, even a negative, that is larger than 1, then the graph is going to be a vertical stretch. If the number is a fraction or a number between 0 and 1, then it's going to be a compression. The reflection comes only if you have a negative value in front of the A. If the parentheses are gone between the X, there's no left or right shift. So you must have this parenthesis right here for there to be a left or right shift. If this is a plus a number, then it's a left shift. If it's a minus a number, it's a right shift, which kind of is backwards to what you're used to on a number line. The plus K value tells you if it shifts up or down. So if it's plus K, it'll shift up. If it's minus K, it'll shift down. And that's what you're used to based on the y-axis. All right, so some examples. This is problem number 2 from your Google form. It says the graph g of x equals x squared was transformed to create the graph of h of x equals 1/2 x squared minus 3. Okay, so I'm going to start just with the parent function, which was x squared. Now they're asking us what happened when it went to 1/2 x squared minus 3. Well, we have this handy website. It's called Desmos, and we can actually tell it to graph the parent function. And then we can also tell it to graph the new function, which was 1/2 x squared minus 3, I believe it was. Okay, so if you take a look at this graph, you'll notice that not only is it shifted down, it is also wider than the original, which, if you remember, if your A value is between 0 and 1, which 1/2 is, then it is a compression, a vertical compression, which is not an answer choice, but it's definitely not a vertical stretch, because that would mean narrower. So the vertical stretches out, and horizontal stretch is the same thing as vertical compression. I do wish they had changed the vocabulary on that, but since it's an image, I couldn't change it for you. So it has to be either A or C, because that's equivalent to a vertical compression. So now let's figure out if it's a vertical shift or a horizontal shift. And yes, I know they spelled horizontal wrong, but I can't correct it because it's an image. So this minus 3. Is the minus 3 in a parenthesis or is it outside of a parenthesis? It's outside because there is no parenthesis there. So the minus 3 tells us it's either going to go right or left. As I said on the previous slide, your K value runs just like a number line. So if it's positive, it's going to the right. If it's negative, it's going to the left. So in this case, it's going to go to the left 3 units, and that is a horizontal shift, not a vertical shift, because vertical means up and down. Okay? On to the next problem, which is number 6, still from your Google Slides. I don't really know why it says Q and W, because it's H and G. So just ignore that first sentence. the vertex of the graph of H is 5 units below the vertex of the graph of G. So H is 5 below G. So let's say H is 5 below. Let me write that down so I don't forget. Which pair of functions could have been used to create the graphs of H and G? So we know that H needs to be lower than G. So G is going to need to be our parent function since none of them have plus 5. So I'm going to go ahead and I'm going to cross out A and I'm going to cross out D because those have G being lower than H. Okay, so if I go back to my Desmos, I already have the parent function there. I'm going to go ahead and add the other two answer choices, which were x minus 5 quantity squared and x squared minus 5, so we can see the differences. So x minus 5 quantity squared, and then also x squared minus 5. All right, so remember our red is our parent function right here. Green went to the right 5 units and blue went down 5 units. So the blue was the one not with the parentheses. So when I go back to my question, I wanted it to go 5 units below, which means down. So the one without the parentheses is the one that went down 5 units. So Desmos.com is completely free if you have a computer. If you have a tablet, the Desmos app is also completely free. All right, this is from your Google Slides where you're matching the puzzle pieces. I put enough puzzle pieces over on the right-hand side so that you should just be able to drag and drop them and not have to make any copies. That way you can kind of self-check if you ran out of something and think you need more. I'm going to walk you through looking at how to solve these. All right, number 7 says y equals 3/8 x squared minus 4. Remember it said if we don't have the parentheses, it has no left or right translation, okay? So this one cannot be left or right because it has no parentheses. Because it has this 3/8, and that's an a value that is bigger than 0 and less than 1, it is going to be a vertical compression. And I apologize for my terrible handwriting on here. Okay, next we're going to look at the minus 4. The minus 4 is outside of a parenthesis, so that's a k value. So k equals minus 4. So that tells us that our graph is going to shift down 4 units. And I believe they called that a translation downwards. Sorry, I can't fit all that in there, so I'm just going to draw an arrow. All right, looking at number 12, it has a -5 in front of the parentheses. So my a value is negative, and it's a value that is bigger than 1. That tells me 2 things. It tells me, 1, that it's a vertical stretch because of that 5. And then it also tells me that it's going to be a reflection across the x-axis because it has a negative in front of it. So now I'm looking inside the parentheses at the the plus 6, and that plus 6, since it's inside, it's going to tell me a left or a right because it's inside the parentheses. Now this is the only tricky one because you want to think that plus 6 tells you to go to the right, but plus is actually going to tell us to go to the left. Minus tells us to go to the right. So this is going to be a translation left. Or I think it's actually in the reverse order on the card. It says left translation. All right, so our last example is number 15, and our A value is 1/4, which is between 0 and 1. So that's going to tell us that it's going to be a vertical compression because it's going to get wider. Then inside the parentheses, we have that +1, which if we look up here, inside the parentheses tells us left or right, and plus actually tells us left. So it's a left translation. And then lastly, the -3 at the end is a K value. And if our K is negative, it tells us to shift down 3 units. So it's a translation downwards. Alrighty, so that concludes the lesson for today. What you need to complete this week is the Ed puzzle that's due tomorrow. It's basically another video explaining the steps on how to do this. The Google form is the first 2 examples that I did today. It's multiple choice. If you do poorly the first time, please email me and I will reset you. I will give you 2 tries. The Google Slides is the matching, the one where you drag and drop the transformations. And then the extension activity is the Imagine Math. Please remember that Mr. Bingham has offered to shave his head if we hit, I think it was like 100,000 minutes, which if we have 700 students is completely manageable. So if you'd like to assist in that, it is a quadratics pathway and it covers mostly graphing quadratics as well as the quadratic formula. I hope y'all have a great weekend. I miss you guys.